Yeah. Hi, we're the team number 3, and this is our presentation for the Assessment 5. We are Giovanna Michelle Orac, Victor Manuel Hernandez, Ángel Geray Sara, and me, Valeria Lucio. So first, we have our problem statement. The amount of solid residues that pollute the environment is growing exponentially each day. As time passes, the population grows even faster, so all the trash generated per family increases too. The UN estimated that at least 30% of all produced food is thrown away. As a solution, we focused on waste such as aluminum, plastic, and those that are not easily to degrade and that end up in places like the streets and finally in bodies of water. We're talking about a garbage compactor looking to reduce the space these wastes occupy on the planet. So here we present our proposals, and because of the previous problem, we decided to design each mechanism that would help reduce the space garbage is covering to this day.
In the first proposal, we used this mechanism that was made of 2 gears. So when you pull up the handle, the gear should move the length that in the drawing forms a triangle. And once the limit is reached, the can will be crushed. This mechanism has 3 links, 2 joints, and 1/2 joint. So therefore, there is 1 degree of freedom.
For the proposal number 2, we have this mechanism that is formed by 4 links and 4 full joints. In this mechanism, as the handle moves down, the block goes in the same direction, and between the space of the handle and the block, there should be placed a can. As you can see from the calculations, this mechanism also counts with 1 degree of freedom.
For the third proposal, we inspired some kind of stapler machine that we can take this movement to crash the cans. This mechanism is formed by 4 links, 4 joints, and no half joints. And then again, the degree of freedom is 1.
Well, for the last proposal, proposal number 4, it was a famous slider crank that moves with angular velocity on a circular motion while the slider moves back and forward. This mechanism is formed by 3 links and 4 joints. And if we substitute these values on our degrees of freedom equation, we have a result of 1 degree of freedom. Now for our definition of requirements. One of the requirements was that our mechanism should have an automatic and constant motion by adding a motor in order to be able to do the same movement as many iterations as we want. Also, we needed a mechanism in which its velocity could be changed in order to set the number of cycles completed per unit of time as we needed. As was mentioned before, it should have 1 degree of freedom, it should be easy to understand, and it should have a compact size. And well, this is a simple drawing of our mechanism, and where you can see the links, the 4 links, the 4 joints, and the degrees of freedom equation.
Our proposal has the following requirements. First, the engine, that in order to reduce the complexity of our system and not create an expensive device, it would only count with 1 engine, making the operation of the mechanical system easier. Second, we have the power source, that we will be using a low-speed, high-torque DC engine, since an AC engine will rotate at a high speed, which will not allow there to be an appropriate amount of time to remove the already crushed residues and place a new amount. Third one, the size, and in SolidWorks, we use a measure of 0.4 meters for the first time. For the second, we use 0.5 meters and 0.07 meters for the crusher. These were of course measured for a study purpose. And the last one, degrees of freedom, that in our proposal is limited to only 1 degree of freedom to be capable of performing the action needed to convert the garbage placed.
Now for the design selection, we chose the slider crank mechanism. This is a very common mechanism due to the fact that it is used in a lot of areas of engineering, such as the automotive industry. Basically, this mechanism has only two kinds of movement, which is an angular movement by the shorter link, which is called crank, and a linear movement by the slider. We chose it because it's its versatility, and it's because it's ease of use with a motor.
For the synthesis of our mechanism, we use mathematical analysis using the initial variables in order to proceed with the calculation. And in this case, we only calculate the position and velocity. First, we use vectorial equations for position that were decomposing scalar equation so we can obtain its values. Then the velocity was calculated with the same steps as position, and the final results were the angular velocities of the road and the slider.
And now we go to the SolidWorks simulation. As you can see, this is our mechanism, and these are the graphs that we should be obtaining. So we're going to go watch the simulation, and we will later reopen our graphs. As you can see here, we are recalculating all the graphs. We added about 3 points to our design. And we added a velocity vector and a distance vector so that we could watch the movement while it's being calculated. We now again ask for the software to show us the graphs that we obtained. And this is the movement that our mechanism is doing in the motion study.
Next up, we have the MATLAB simulation. For the MATLAB code, we use two formulas regarding angular velocity of the crank and linear velocity of the slider. These formulas were directly taken from the design of machinery by Robert Norton in 2020. Next, it's a screenshot of the MATLAB code, as well as the graph that you should throw. Next up, I will show the code working. Now we have a small peek of the code, and now we're gonna run it, see what it does. Here we have the first graph. This is the slider linear velocity. Next, I'm gonna show you the angular velocity graph. This is the angular velocity of the crank. Now returning to the presentation. We should see in the next slide a comparison between the MATLAB and SolidWorks graphs. As we can see, they both resemble a similar movement behavior. That's what we were looking for, both on the angular velocity and the slider linear velocity. They both resemble a similar behavior, and that's mainly because we use the formulas that were for the slider crank mechanism for the MATLAB.
And that would be all. Thanks.